Good morning, good day, and good evening. I'm as your host, Brady Robertson, and this has been a mess of technical difficulties today. We went from Discord to Jitsi back to Discord. Turns out it wasn't no, initially it was your webcam's problem. And then it turns out the Discord also has some tech issues. So then now we're here. We're on Jitsi. This is why you should always have backups. Anyway, that's not what we're here to talk about. We're supposed to be talking about Coreboot. So how about you introduce yourself and then we can get basically straight into it.
Okay, so hi, I'm Elly. You might know me from my work done on Chromebooks. Like for the past 3 years, we mainlined most x86 systems. I also do some stuff with post-market OS recently, a little bit of Fedora, and also right now we're starting to work on ARM. And before I start, I should say that all any opinions you might hear are completely my own. Like there's despite my affiliation with any projects or companies that may work for, all opinions are my own and are not representative of any stance of project or the company.
Fair enough. Fair enough. I guess before we get into anything more technical, at a high level, what is Coreboot? Like, what does it actually do on your system? And I guess from there we can go into why someone might want to use it.
Right. So Coreboot is mostly just doing the hardware initialization part. Before Intel Skylake rolled around, where they introduced so-called Intel FSP, it's most of the hardware initialization was mostly done in Coreboot. Like up to, I think, even recently, one of my colleagues, Angel Pons, reverse. I think they might have reverse engineered it. I'm not sure. But basically everything except for memory initialization, which was done in as a blob, was open. So now, because of the complexity of x86 systems, mostly, although it's also the case with ARM, which we'll get into later, like Intel and AMD provide you with so-called firmware support package, which is basically a very slimmed down version of EDK2 platforms that you can only get under very strict NDA. So Coreboot is basically loading FSP, and which is doing the hardware initialization, and Coreboot is telling it to configure, let's say, hey, you should set this parameter, like let's say this amount of VRAM, or you should set the memory controller to those settings or voltages. But basically, you almost never see Coreboot unless you hook up the serial output and enable debug, because when Coreboot is done with initialization the hardware, it passes control to so-called payload. So back in the day, we used CBIOS as a payload, which provide you with BIOS calls, so you can boot like Windows, I don't know, XP or something. You also have Linux boot, which basically Linux kernel is used to initialize like frame buffer and so on. And like on Chromebooks or System 76 is using EDK2, very slimmed down version of EDK2 called UEFI payload. So when you, for instance, I know that you own one of the Chromebooks. So when you press the power button, when the screen comes on, that's not Coreboot at this point. That's already EDK2.
So there's one. There's one term you used in there that I probably should define for people. What is FSB?
FSP. It's called firmware support package. So you get
Okay. Yep.
Yeah. So you on some platforms it's 3 binaries, on some platforms it's 2, because Coreboot is doing like when Coreboot starts, it first needs to initialize the bare minimum in, I believe it was in CPU cache. Then it needs to initialize the memory, and then everything else, like I think interrupt controllers and whatnot. Of course, there are more to this depending on the system you're using, because well, let's say on Intel side of things for now to make it simple to understand. So when Coreboot first starts, it starts loading either FSP-T, which is temporary RAM initialization, and then it's calling, I believe, I actually forgot, so I will have to check. But I think first is FSP-M, which is initializing the memory controller. It's training the DRAM, and then it's initializing the, like in secondary CPU cores and so on. It's FSP-S, which is FSP, like FSP-T stands for FSP temporary RAM initialization, FSP-M, FSP memory initialization, and FSP-S silicon initialization. So that's how it's done on x86 currently. So because companies like Intel don't want to have their code they're using to initialize the platforms publicly available, they just give you the binaries that are, you can find them on their GitHub, not for every CPU family, but for most of them. And you can basically control them via the API.
So when we look at a regular system, like you just buy some motherboard, just, whatever it is. So this is using a standard UEFI, and my understanding is Coreboot is sort of taking the place of that system.
Exactly. So when you buy a mainboard or laptop these days, it will come with firmware from one of two companies. One of them is American Megatrend, and the another one is Inside H2O. Both, from what I know, both companies are getting so-called platform reference code. Sometimes it's FSP, sometimes it differs. But basically, they get like a EDK2 from vendor like Intel or AMD, and then they add their own modules for, like, when you go into UEFI, when you get like a MSI or Gigabyte or Asus, different vendors, they have their own setup programs. But under the hood, it's all just EDK2 basically.
Right. So they usually like brand it their own way, so it looks like their own thing, but under the hood, it's either one of these two companies.
Yes, exactly.
A fun example of this is on the Steam Deck, they have a very, very, I don't know why they've done it like this, but the UEFI they have is very minimally branded. So it's got like Inside H2O like all over, like all over it. But like if you go buy like a Gigabyte board or something like that, anyone who's gone into the UEFI or on an older system on the BIOS would have seen the way they handle it in like their own, I guess, whatever skin they want to apply to it effectively.
Yes, so I think that two companies that I know from the top of my head using Inside H2O is Valve on the Steam Deck and also Framework.
Okay.
Yes. But from what I recognize, like all the major like mainboard vendors, all of them are using AMI.
So when we look at the Coreboot project, why would someone actually want to go and use Coreboot? And there's separate reasons why a company might want to go and take their device and get Coreboot working on it, get Coreboot ported to it. But if somebody was to go and buy, people like to go and buy old ThinkPads, for example, and they like to chuck Coreboot on it, what benefit would someone actually get from going and using Coreboot?
Yeah, so that's an excellent question. Like, first from the top of my head, I would say is the security, because after, like, let's say, I think 4 or 5 years, when AMI no longer supports the platform, of course, if you have like a business vendor like Lenovo or HP, They usually have longer support contracts for the workstations and so on. But usually when that time runs out, or sometimes even earlier, like 3 years, uh, or if you buy like a mainboard from like less known company, let's say you're buying like OEM, like Medion, something like that, it's likely you will never get updates.
Mhm.
And because all of that is usually based on a very old code base, you get security vulnerabilities. Like you saw logo fail, pixie fail, all of that was fixed in upstream indicate tool a long time ago. But firmware development, when it comes to like proprietary firmware, is still a complete mess. Like there is no Git, there is nothing. It's just they get like a package from a vendor,
Mhm.
like EMI or inside H2O. Like let's say 2 or 4 engineers are working on the firmware, and then they test it and they say, okay, we're good to go. Let's go to production.
Mhm.
And then when it comes to time to update it, and they're like, okay, like stuff broke. What's wrong? Why is it not working? You know. So oftentimes, like you saw a fiasco with, I think Asus last year, when they had issue with blowing up CPUs and so on.
I don't think
Yes,
I remember this one actually. uh,
I believe it was AM5. They didn't have like
oh.
proper protection mechanism in place.
Oh yeah, okay. AMD's new Ryzen 7000 processors are currently being affected by a bug within the BIOS. Yes, thank you, Dexerto. No, we've moved it past the BIOS already. Causing him to burn up. Oh,
Hmm.
okay, yeah, that's a problem.
Or like when this year, when you saw the Intel CPUs getting damaged.
Mhm. Yeah,
In
yeah.
order to fix that, you need to update the microcode.
Mhm.
But then it requires the vendors
Mhm.
to deploy the update, and all users have to update their firmware. Which, spoiler alert, almost nobody does,
Yeah,
even though they should.
yeah.
So
I've only updated the. I've only updated once, I think, and that's because for some reason I started having weird boot issues. I don't know what it was, but it seemed to have been linked to some need to update. I did the update and everything was fine. But besides that, I don't think I've ever gone out of my way to do so.
yeah, so that's the real problem. Like you have all the security vulnerabilities, microcode updates in case of AMD, for instance, AGISA updates, and like people don't update their systems. And sometimes, for instance, right now in front of me, I have Ryzen 7000 ThinkPad. And the reason why I switched to Sway yesterday, literally, is that I'm having weird random lookups with my GPU. Like either it resets my GPU or it's just straight up freezing. Also, Wi-Fi card, if I suspend the laptop and resume it, it works with 1 megabits per second. And if I hibernate my laptop and then resume it, the Wi-Fi completely drops off the bus.
All right.
And it's
Yeah.
a modern machine with that's still supported. It's literally been bought 2 months ago on the newest firmware.
Mhm.
And we know that AMD fixed some bugs with GPU in the newer AGISA,
Mhm.
but now because I cannot do anything with the firmware, I have to wait for Lenovo to push update. So yeah,
So it's sort of the if you're looking at it more, I guess a similar example, right? If you look at the way that especially more so in the past with Android ROMs, where you'd have these different vendors that all controlled when your phone actually got an update, and then you might have a phone that's a year old, and they're just like, yeah, we just don't want to support it anymore. Like, enjoy all the security issues, have fun. It's not our
mhm.
problem now. So it's the same sort of idea there.
um, yeah. So in defense, we will do on a bit of attention here.
Mhm.
That is actually often a fault of like Qualcomm or MediaTek. Like right here, I have a VR/AR headset from company called Lynx in France, right?
Okay.
It is currently shipping to backers on Kickstarter.
Mhm.
It has Qualcomm XR2 SoC, which is like what, 3 years old, maybe 4 years old, and it will likely not get another Android update, which is currently Android 12, because Qualcomm apparently will not support that SoC anymore.
Mhm.
And so device that is currently shipping to users, that I know the XR2 is being used by, I think, like HTC in their new release VR headset. It's stuck on kernel 419.
Well, wait, is 49? What is the bottom of the kernel support range? Is 419 dropped already? I don't remember. I think no. 419 is the
just
next one
for
to
that.
be dropped.
Yes.
Now, whether it's actually running a updated version of 419, that's another question. I really doubt it would be.
Yeah, so that's also another problem, is that the way Android is written, you have all the custom patches from like vendors, and it's 419, but it's not 419, you know.
Right, right. Right, it might as well just be something that's no longer supported with how out of date it very likely is.
Yep, exactly.
Yeah, you know, OEMs, we love them. It's great.
Yep.
So, okay, okay, here's one thing. If we get like some sidetrack and that I'm gonna just try that one again. If we go down some sidetrack, that's totally fine. And if we don't talk about Coreboot for like 20 minutes, totally fine by me. But one thing I did want to get into regarding Coreboot is we talked about like why someone might want to go and actually install Coreboot on their own system, but from the perspective of like a System 76 or a company that wants to sell devices that are core booted, why might they want to go and do so?
Right. So right now in the EU, I'm not sure if the law already passed or it will be soon. I think it was called digital sovereignty or something like this. Basically requires like, I'm not sure about the requirements, but I know that there is a certain time that devices have to be supported for.
Mhm.
And like, if the company doesn't care about the device after like say 5 years or something, they should in they should release the source code so that people can, who are still using those devices, because spoiler alert, my phone is 3 years old, it's still perfectly fine. So like, if a device is no longer supported, and they should be able to stay safe, stay up to date as much as possible, and not be forced to upgrade the device just because it doesn't receive security or feature updates from the vendor.
Mhm.
So by going with the open source route, when you like publish the code, it's all GPL2. Often when you're a system vendor, when you publish the code, of course you still have some to test it sometimes, but if you open source it, then the community can help you or even maintain the systems down the road. The best example I would say is PC Engine's APU 2.
Mhm.
I think it's a very old system, about a decade old, used as a router. And I know that 3MDEP is currently still supporting the Coreboot port on those systems,
Mhm.
so that people who bought like PC Engines back in the day, they can still use it and be up to date.
Okay, no, that's fair. That's fair. So it's how would I say it? I guess it's just the same general benefit of most of the FOSS world, right? Where if people have a reason to keep using something, they have the ability to keep it alive, as opposed to the vendor decides, well, it's just e-waste now, and
Mhm.
buy something new effectively.
Yep. I mean, prime example here would be what I have on my desk currently. So this is a 2015 15-inch MacBook Pro,
Mm-hmm.
which Apple no longer supports. However, it works mostly fine under Linux. The only problem is the Broadcom Wi-Fi card.
Mm-hmm. Mm-hmm.
As Windows, 1 second, I will try to put it down as quietly as possible. Uh, so of course, Apple EFI is not very great, but you can install Linux on this and still have decent performance. I mean, it has 4th generation Core i7. It has 16 gigabytes of RAM, and I installed, I think, 500 gigabytes NVMe in it. And it's 1920 by 1200, I think, or no, it was like a scale resolution, but
Mm-hmm.
it's still a very nice machine to use. I could do most of my work on this machine.
Mm-hmm.
And Apple dropped support for it. I think it's still getting like security updates, but will not get any more after, I think, the next 2 years.
I'm surprised they're still supporting it at all. Wow.
Yeah.
For all the criticism that Apple might get, deservedly so, I will say that they do tend to give their devices a fairly long support period.
That is true. Like, I think that on average they have like what 6 years for iPhones, and I think 6 to 8 years for MacBooks, which, realistically speaking, after like a decade of using a system, it's not that the system doesn't last; it's that you don't last with the system because the software is getting more like heavier and heavier, right?
Right, right. Well, there's also a lot of MacBooks that don't survive 6 to 8 years. Like, if especially if they're Chromebooks are a good example of this as well. If they're used in a school environment, it is very unlikely a lot of them are going to survive that amount of time. I was at a school that had laptops. That was already a thing when I was going through school, and yeah, there's a lot of people that don't treat them well. We'll say throwing
Yes.
them. Especially my school it was really bad because we had MacBooks, so they were throwing $1,000 bricks around, and like it's one thing if you're throwing around like a cheap $200 Chromebook, but look, there are some people that have literally zero respect for anything that they are given.
Yes. Unfortunately, I can agree with that because sometimes we get teenagers on our Discord related to Chromebooks who literally are posting themselves destroying the school property and stuff, and we're like, why? What? What?
Yeah, if you want to install Linux on a Chromebook, please make sure it is your own Chromebook. Do not, especially if it's one of the older ones that actually did require like physical intervention to go and unlock it. Like, please don't go and start bridging pins and soldering things on an old Chromebook unless you actually own it.
Yes, that's so the big problem we have was that you see teenagers swooping in and be like, "Oh, I want to install Windows on my school Chromebook," and we're like, "No, don't do it. No, don't mess with school property. You will get in trouble."
Yeah, that actually reminds me of I had someone on the other week who does like malware research and things like that, and he has a bunch of people joining his Discord asking if there are ways that they can circumvent proctoring browsers. It's like, No, don't. Yes, there are ways you can get around it, but just do your exams. Like, just don't try to get around people monitoring you doing an exam. It's going to go a lot worse for you if they catch you.
Yeah, and considering how how logging and all the monitoring software in schools work, because I've seen like the Google's management console and whatnot, they will know.
Yeah.
Because they can literally see Chrome OS daemons and other logs in the console. They just have to request it from the device, but they will know if you mess with it.
Yeah, I get why people want to, but same with the Chromebook thing. I get why you might want to go and install Windows on it or install Linux on it or whatever you want to do with it, but like, just don't.
Yeah.
Just don't.
Yeah, I mean, I get it. I mean, I was a teenager once, and doing something that you're not supposed to, like being a hacker, like hacking your phone or something. It is pretty cool. Like especially when you're a teenager, but don't do this on the school's property, right?
Sure.
Like it was the same. Like back when I worked for IBM, I was given a MacBook, and I was told, no, if you have a MacBook, you cannot install Linux on it. So, I knew that, it was a company property. If I would mess with it, I would get in trouble because you also, you have all the contracts in place to make sure that it's compliant, blah, 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 blah. So, if you need something else, use a virtual machine or use your own hardware.
Or if you want to have fun in non-destructive ways. There are things you can mess with that aren't going to ruin the machine.
Yes. I mean, to be fair to Chromebooks, at least with Chromebooks, if you have SUSE cable or this thing, you can actually recover from flash fairly easily.
Ooh.
Yeah. Yeah. So this is probably not something you will see publicly. This is Google Servo V4. Mostly, I haven't been able to get it to work with TI-50 devices, but on CR50 with one USB-C, you will get access to like a Ethernet port and video output. Pretty cool.
That is pretty cool. Well, I guess we can talk a bit of. I do want to actually do some more.
And this is the original one that you cannot really buy anymore. We have like 4 in the office.
Oh yeah. I do definitely want to do more stuff with the So I bought the Chromebook like 2 or 3 months ago. I was getting ready to do stuff and then I got distracted by other things. I want to do a you know how people do those like switch to Linux videos? I want to do one switch to Chrome OS just because I think it would be funny. But I keep putting that video off. So because I'm putting that video off, I'm putting off messing around with the Chromebook and chucking Linux on it and things like that. But okay, for anyone who actually is interested in going ahead and doing that, like, how? For anyone who has no idea what they're doing, firstly, if they want to buy a Chromebook and they want to stick Linux on it, what should they be looking for with that? And once they've got something, sort of what do you do with it? How do you even start to get anything that's usable?
Right, so we have documentation at docs.chutrabook.com. Yeah, this name is a mouthful, but that was Coolstar's idea. So basically, we go over through unlocking the write protect, which on most TI or CR50 devices is either disconnect the battery, boot with USB-C power adapter that supports 15-volt power delivery mode, or if you have SUSE cable, you can just do this without opening the device. There is an exception to this, being Intel Jasper Lake platforms. On Intel Jasper Lake platforms, you need to open the device and find the jumper, and not all of them have it. There is a trick you can do. Do I have anything with SPI chip that I can show? Probably not on hand, but when you have the SPI chip, you have 8 legs. Let's say you have chip select, MISO, write protect, ground, VCC, hold, MOSE, and clock. If you breach pins 3 and pin 8, that is write protect and VCC. While the system is running, you can run a flash ROM in the loop with write protect disable, and then you get rid of the write protection without using anything but a paperclip. But then again, you need to know hardware and how to do that, right? But once you get over that, you flash the firmware and you basically grab, as long as it's x86, because ARM is still a work in progress, you basically grab like a distribution like OpenSUSE, Fedora, Arch, anything that is fairly recent. It has to have at least kernel 6.6. So as long as it has the kernel 6.6 or newer, and there is an exception to that rule, if you have Ryzen 7000 Mendocino, you need kernel 6.8 to have properly working audio. But other than that, as long as you use like up-to-date distro, then stuff mostly works. With and post-install, you have to do 2 steps. One, if you have Intel Tiger Lake, which is 11th generation or newer, like 11, 12, 13, I think 14 gen, you need to get our workaround to load kernel modules in appropriate order. I still haven't had time to fix this bug. It basically comes down to you have in 11th generation Intel introduced so-called Intel PMC MUX or something like that. Basically, when the Linux loads, it wants to load the, I think it first loads the Cross EC Type C, which is a Chrome embedded controller module first, and that prevents the PNC MUX from binding correctly. If you unload both of those modules and load Intel PMC MUX first, then Cross EC Type C, then USB-C will work correctly. And then you also need the Sound Open firmware, basically like firmware blobs, which on most distributions should be installed by default, but not all of them do. And from Tree, and his nickname is Weird Tree Thing on Git and stuff. You basically have to get UCM, which is also use case manager config files. It basically tells ASA and Linux how to use and how to configure the sound card. Then once that you have those 2 things done, you reboot and basically everything should be working.
Should be.
Yeah, I mean, sometimes you get into edge cases where, you get platform that we haven't really worked on. Like, we have some people who buy like brand new 14, 15 gen machines and, and considering we support over 250 machines at the moment, it can be a bit challenging for people.
Right. So if you want to have a better experience, you're better off finding something that is on the supported list and going with that. But hey, if you want to have a bit of a journey and see what happens, there are new Chromebooks always being made.
I mean, that's basically how I first got into like proper Linux kernel development, because back in 2022, I bought a Chromebook that wasn't supported, and while trying to flash beta firmware from MAT, I bricked it. So I jumped onto Discord and we started talking. We started working on the patches, getting it working. And before I knew it, people started reaching out to me. Hey, I have this hardware I don't need. Do you want it to add support and stuff? And
It just went
I
from
would say
there.
yeah, I mean, if you just want to start working with like either kernel or firmware development, I think that's a great place to start.
So before we I think like yesterday or something, you said you were going to have a pile of Chromebooks. Do you actually have those with you?
Yes. Okay, which one you want to see the first?
Whatever you want to grab.
So the first one on top of the last is the latest one.
Mm-hmm.
This is Kohaku. It's a 10th generation Samsung Galaxy Chromebook. It has a very nice 4K AMOLED screen.
Ooh.
I'm not gonna let it boot because it will take a moment, and I will have to type in my Lux password. But it's actually very nice. It has
Ooh,
fan
stylus.
support. Yep. However, as a part of the project, we usually find a lot of design flaws in the hardware.
Uh-huh.
In this case, you see this machine is so thin, it's fanless. It's a 10th generation fanless Core i5.
Uh-huh.
As you can imagine, it runs pretty hot. It runs so hot that it destroys the trackpad and the backlight circuit.
Does it... Wait, is that like a problem with it running too hot under Linux, or does it do that under Chrome OS as well?
Yep. It also does it on Chrome OS. Like people running Chrome OS were reporting that their trackpad stopped working, and after sending it to Samsung, they replaced the top case with trackpad and stuff.
Oh my god. Okay. Wait,
Yeah.
let's see if I can... Oh, yep, that... I put in Samsung Galaxy Chromebook O, and the first thing is overheating. I see. Why is my Chromebook so hot? I think my Chromebook is overheating. How to overheat a Chromebook? I don't know why you'd want to know that. Yeah, okay. It sounds like this is a badly designed device.
Yep, and it keeps going.
Mm-hmm.
This is Elrate, HP. Let me double check that. HP Chromebooks X360 14C, which is 11th generation, and it tends to lock up for random, and not all of them do. And we found that most likely the cause of the overheating is that here you have like a round trips that are covered with heat shield.
Right.
And it's very close to the CPU. So if we still are trying to debug this because only me and the other developer have the same problem with this machine.
Mm-hmm.
But if you install the heat shield as it is by default, it you see that the embedded controller is reporting external press hot asserted, and either your system slows down to a crawl because it starts to throttle, or it just freezes.
Right. Well, at least it's not melting the trackpad.
Yes, although I have to say that battery life on this is pretty decent. Like, according to reviews, it was like 6-7 hours in Chrome OS. Mine has 80% of the battery life left, and under Linux it's lasting 8 hours.
That's pretty impressive.
Yeah. And later I can hook it up to the HDMI and show you a thing you can do that people usually don't think they can do on the Chromebooks.
Hey.
This one is one of the ARM ones. I got it from a person who saw my talk at the Chaos Communication Congress. if I boot it up, it should boot into Fedora. I'm still working on firmware, and I think the battery might be dead. Oh, that's not a very good live demo. But yeah, basically, we're working on that. We're at the point where most stuff works. Video output is not working, but there is no standardized way to boot Linux on them yet. So I'm working on U-boot, which will provide like EFI capable payload. It's kind of like what Asahi Linux does, except instead of chain loading, in our case, we will just take Coreboot, which will do hardware initialization, load U-boot, which will enable the frame buffer, and so on, and then just boot into like Linux kernel, like systemd boot, whatever. And I have another one. But wait, there is more. Yeah. So this is Crane. This is Lenovo Duet.
That's a cute one.
Yep, it's a tablet. And okay. I think I also forgot to charge it, and something is stuck to the magnet. I forgot to charge it, but basically I have a post-market OS running on it. And the nice part about Chromebooks, the modern ones, is that if you have so-called USI pen, Universal Stylus Initiative, you can use one pen on all of them. I know that I think Tuxedo and some other vendors also adopted that technology. So
That's
it's
cool.
to like $20, yeah, like $20 stylus. You get like pen pressure. You don't get the tilt, but you can actually draw with it.
That's cool. Actually,
Yep.
I can grab what I have up here. One of the ones is really dumb. I don't know if I've shown it on the podcast before. This is how long I've had it sitting on the shelf for. There's dust on it. This is the normal one. This is the what is it? CX5501. I don't remember what generation this was.
It looks like it has 16 by 10 screens, so that seems
yeah.
nice.
That's the sensible one that's gonna do normal things. I showed this on a stream. Yeah, this is the ship box. This is the what is it, like 2012 Pixel book or whatever it was.
Yeah.
Just Haswell Chromebook that's basically e-waste, but it's funny and I wanted to buy it.
Oh, I told Link was Ivy Bridge.
Was it Ivy Bridge? Maybe it was Maybe it actually might have been Ivy Bridge. Yeah, I don't even remember what it was now.
Yeah, like I also
it was Ivy Bridge. Yeah.
Yeah. So I also have, we could say, shitbox here with a bunch of stuff on it. This is so-called HANA. I stole Wi-Fi antennas from it for the project. It's a MediaTek 8173 with Power VR GPU.
All right.
And yeah, to say that it's causing a lot of grief will be an understatement. It's a shame because it is decently fast still. But with the Power VR on mainline, like I got it to work somehow, but it just it's just not worth it. Yeah, so I don't have any more, but I do have one more, or rather two more devices running Coreboot, which this one is currently being reviewed on Gerrit. It's like Intel N100, which is Alder Lake N with 2.5 gigabit Ethernet ports. I just slapped a cheap 16 gigabyte DDR5 stick in it, 1 terabyte NVMe and Wi-Fi 6 card. And for like 200 euros, you get pretty nice passive firewall.
That's cool.
And the funniest one by far will be this piece of junk.
Okay.
Like you might have seen like tech reviewers reviewing this mainboard like last year. It is a Chinese mainboard with laptop CPU
Oh, it's that
that is running
one.
engineering sample, a laptop CPU on a desktop mainboard. I have two of them. This one is the one with the engineering sample. And in the next, I think, 3 weeks, we should be releasing Coreboot 2411 with support for this mainboard. I had it working since March in my main desktop, and it's rock stable.
So that's just a fun one. Like there's no is there like any reason why that one's like being worked on? It's just like might as well do it.
Yeah, so I bought it because I thought, it will be funny if someone ported Coreboot to this weird mainboard with engineering sample laptop CPU, you know. And I did, and the performance is pretty decent because for about 160 euro, I got a mainboard that has similar performance to Core i5 13th generation.
Okay.
And the mainboard itself for like 13th generation costs about as much. So it's a win for me. And it's also the only mainboard in Coreboot 3 with DDR4 XMP support. As of time of our talking, you still have to enable it, but because enabling XMP by default is not something I want to do. Because, for instance, the RAM sticks I have at home are kind of damaged. I lost the receipt, so I cannot return them to the store. But if I enable XMP, they just spew the data corruption. So yeah, that's why I don't enable XMP.
Yeah, it's probably the best then. So on that topic, when you have a device, whether it's something more sensible, and you want to sit down and port Coreboot to it, what is that process like? Where do you start, and what does porting Coreboot even involve?
Right. So first is the very important step to check if your system does not have Intel boot guard. It is very similar to like blowing ifuse on like CPUs and phones, or AMD also has platform secure boot on Ryzen Pro CPUs, which prevents you, like once manufacturer deploys the firmware and boots it for the first time in the factory, it blows the ifuse in the platform controller hub, and then from that point onward, if you would modify the firmware that will invalidate the vendor signature, it will not boot, no matter what you try. There is an exception to that. I really hope I will pronounce their name correctly, but Mitkuri found an exploit for 6, 7, and 8, I think also generation CPUs, which allow you to bypass Intel boot guard because it's done in the management engine. And I know they're currently working, I think, on ThinkPad T480. But since this is an exploit, it is a very dicey topic.
Right.
So let's talk about desktop mainboards first, right? So from the moment you connect the power supply and if you want to like press the power button and so on, you have this, let's call it the microcontroller called Super IO. If you're building PCs, you might have seen them from like companies like ITE or Nuvoton, usually around the PCI Express slots. When you give it 5-volt standby power, it powers on, loads its own firmware usually, and it's basically controlling stuff like front panel, like buttons and LEDs. It controls fan like PWM. Like it monitors temperatures from the system, voltages. It's also like if you have PS2 or on older systems like LPT or RS-232, that's all in the same package, the controller. That's why it's called Super IO, because it integrates all of that functionality. Then when you press the power button, it sends, basically starts the boot process. When platform controller hub starts, in case of Intel, it loads the management engine, it checks the signature if the boot guard is enabled, and then it starts loading the host firmware. So the first thing you need to have to port Coreboot to desktop mainboard is datasheet for the Super IO or embedded controller. To know which logical device numbers it has, you need to know which registers you can configure. If you're lucky, you can just like create like a dummy driver that will work. But you will likely not get like fan control and stuff working. Then you need to have, like, if you boot the system, like you need to disable secure boot. You need to boot Linux with IOMEM relaxed, which allows you to access some registers and stuff. So I think the first thing is that you need to grab like DMESC, of course, LSPCI, LSUSB, then run Super IO2. And I'm in the process of writing new mainboard porting guide. So when that's ready, then I will just let people refer to that. But basically, you grab all the information. You also need to dump, if you have iGPU, you need to dump VBIOS, which in case of Intel is called video BIOS tables. It basically tells which outputs are enabled, if it should enable hot plug detect, and all of that. You also need to grab HD audio verbs, which is basically telling the codec which outputs are enabled. And of course, GPIO. GPIO is very important, and you really shouldn't mess with them if you don't have much experience. You can dump them from the currently running firmware, but it's very important that if, for instance, GPIOs are configured as output or as input, you don't switch them, because you can damage your mainboard by switching GPIOs if they're configured in a different way. So the first thing I would recommend is looking if someone already ported Coreboot to similar platform. Like in my case, for that arraying board, I based my port on System76 ORIP8 because it was the only platform in Coreboot with Tiger Lake Cage, which is like almost the desktop level chip, but it's still mobile. So from there, I looked at how they configured FSP, how they wrote the device tree, and so on, so on. So I started writing it by basically cleaning the device tree, cleaning all the specifics to a System76 embedded controller, and some GPIO configuration, and so on.
One thing before you keep going, what is the device tree?
Right. So in Coreboot, it's not the same as U-boot, for instance. You get, maybe I could actually show you how that looks. Maybe that would be easier. because it's nice to have visual representation. The question is, can I start the screen sharing? Let's say use operating system settings. Okay.
Okay.
All right.
Oh, that actually worked. Wow.
Yeah, but I will ask you to blur at my, the Jitsi when you will be doing editing, like above the Jitsi, my tabs that are open.
Oh,
But
that's fine. That's
fine. So let me make it bigger for others because we have like 4K screens here. So let's go to projects, personal. Maybe if I can close this, yes. Use yourself, but hopefully that's fine. Coreboot, let's go to Vim, source, mainboard, airing, yes. Tiger Lake device tree. So you import this line, which is, if we go to CD source, I think it will be in SOC, Intel, Tiger Lake. So basically this imports that path. And then if you look at the, you have so-called chipset PCH.cb. And you see that it looks very similar. It basically just shows you which devices are default state are off or on, which you can enable by doing override in device tree. And for instance, here you see that I'm configuring it to have power limits 45,109, which is default. But on my system, I have, I think, 60 by 120, which gives it more performance. PMC routing. Like I said, this is how you configure the iGPU. You configure certain ports to, and if you want to have like a data channel and hot plug detect. And then this is actually the trial and error part. If you don't have schematics for your system, is that you have to populate like every PCI Express slot in your system. Of course, because when you install the card, FSP usually remaps root ports. So the best way I found it to do is to install everything on, like, populate every PCI Express slot on the system, grab LSPCI, and then, for instance, if we do, let's say, LSPCI-VPP and but of course this is a AMD system, so it will be a bit different. Or maybe if I have any logs here that I can show. I think I can show CD Topton logs. LSPCI. So yes.
There we go.
So, yes, so you scroll to PCI Express, and for instance, here you see PCI Express bridges, and sometimes it's just, for instance, this is Alder Lake, so some systems don't have it. Like in the Linux, it doesn't recognize them yet. But basically, this is like PCI Express root bridge. So I have 1C.1, 1C.2, and then if you look again at the let's go main ports. So for instance, if you see enable root port 1, that's equivalent, let's say 1C.1. Then you can find that information in device tree. But again, this is, unfortunately, if you don't have schematics, that's trial and error. So good luck.
Right.
Yes. But other than that, it's very simple. Like you just enable devices here, which you need, like HD audio. And here you have the Super I/O chip that I mentioned, which controls, like for instance here, I only implemented basics for the serial console. So if you plug in the serial cable to here, we can get the serial output. That's basically when you're doing board bring up, it's the only way you can get useful information. And by you doing that, I can stop sharing the screen. Yeah. So when when you have once you have like device tree, then you have to dump GPIOs and run them through Intel P2M, which takes the raw dump of GPIO and exports it to the list that Coreboot or other firmware can understand them. Usually it's not perfect. Usually you have to do some tweaking because, for instance, on laptops, on Chromebooks, for instance, the GPIOs can be switched on or off depending on what you're doing on the system, like the audio amplifiers and the video outputs that can be controlled via ACPI. So sometimes you have to adjust them, but mostly they should work. So you have let's say you have the device tree, then you have to if you're not porting to the laptop, I would say the ACPI should be fairly sane. Sometimes you need to do some tweaking, but it should be sane. Then HGA verbs, which is basically setting up the HGA verbs to tell the audio codec which outputs to enable and which inputs, like the pin configuration. And then in ROM stage, you enable stuff like how much video memory you want and so on. Then when it comes to compilation, come back to here, make and config, and to allow. Okay, and then when you are going to compile Coreboot, you have this lovely setup. So here it's basically you're configuring the compilation options, which compression you want to set, and so on. On the main board, you select your vendor and mainboard, as well as the size of the ROM chip, which should be populated by default by a kconfig that you wrote. Then in the chipset, you have more options for like, say, if you want to disable the iGPU, you can do this from here. Or, the interrupt controllers. And here you also have to include binaries. Like Intel flash descriptor is like, I would say, it's kind of complicated to explain if you're not in the know, but it basically has like PH traps, like it configures stuff like which SPI chips are supported and so on. Like let's leave it at this because we could get into the rabbit hole. Here you have to add a management engine firmware, which if you're porting a mainboard, you need to know that you cannot include the management engine blob that you dumped from your mainboard because it will have specific configuration for that mainboard and it will likely not boot on another person's board. The way to do this is to get like a BIOS update from the vendor and extract it from there, because then you get clean management engine region that you can include. If your vendor does not provide you with the firmware package, it's best to just skip them and just flash the BIOS region. And of course, here you have like power management. If you have how you want to do display initialization. Like here includes the VBIOS, video BIOS tables. Yeah, this is mostly just if you want to use CMOS or SML store, which is NVRAM essentially. You can enable stuff like TPM here. This is console. If you're debugging, or if you want to have, like for instance, on this firewall, if you want to run the system headless, you can just enable serial, and that way it will just print to the serial, and you can change the boot config and such without having to connect the monitor and keyboard and so on. I can show this later if you'd like. SMBIOS is really nothing interesting. Right, and here's the payload. A second. Right, so in the payload, you basically will see which which payload you want to choose. Like you can select grab Linux boot, which is just like a Linux kernel, CBIOS, which is a legacy like BIOS payload, U-boot, or EDK2, which is like UEFI basically. And then you configure options like if you want to build, say, like if you want to generate a release build, which is like production ready, or if you have any issues with, I don't know, like PCI Express devices or something, then you can select the release build. And then options like if you want like escape key, a logo, if you want the secure boot, PXE, so on. And then in debugging, you can basically choose what you want to have in the CBFS and in the serial output. Then when you're done, you just go make. I'm not going to use all cores because it will be a very bad idea. Let's say J4. It just starts building, right? Now, usually the thing that is taking the most time is building EDK2 because it's another payload. But if even on like ancient system, it wouldn't take that long to build, like maybe 2 to 4 minutes on like Haswell system. And once that is done, maybe we can let it run when we're talking. Once it's done, you get Coreboot ROM that you can flash onto the system, and then just basically start testing if everything works, if you made any mistakes, if if you find any bugs in Coreboot, because sometimes not everything is implemented or tested. And basically it's like rinse and repeat. Like if you made any mistakes, then you have to reflash the firmware. Now the good thing is that if you're flashing the firmware and you just made like some very tiny changes, then flash ROM will do a different diff, and you don't have to wait that long. Like if you're working on the firmware as in like a professional sense, you likely will get something called EM100, which is like FPGA based SPI emulator. Like I have a box of them over here, but I'm too lazy to get up to get them. So you get like a box that you connect to USB, you upload the firmware image to the emulator, and that takes like 2 seconds. So if you need to do any iterations, you just push the new firmware, you reboot the platform, and it's pretty quick. Well, if you don't have it, then you just have to clip the chip and reiterate, but it's still not that much of a problem. Yeah, and then you basically go from there. Like you do debugging, like you try to boot Linux, maybe Windows, because Windows is the one thing that Windows is good at is complaining about ACPI errors.
Right.
So if you have made any mistakes, then Windows will likely do blue screen of death or something, and you know that you have ACPI problem. Okay, and that's basically build image. If we do build /coreboot.rom, you see that will have 16 megabyte file, and that's basically the entire SPI image. Right. Well, when it comes to laptops, it's more complicated because embedded controller is like Super I/O with extra steps, because it also controls stuff like battery charging, like USB muxing, and sensors. Like, for instance, the funny bug that I found with Eldred that I have is that I noticed that my laptop would sometimes just wake up when I had it in my backpack. And I found that when I was running to the tram and I pulled my laptop out on the tram, and suddenly it wasn't in sleep mode anymore. I found that if you shake the laptop too much, for some reason the embedded controller thinks that you opened the lid and removes the laptop from suspense.
Okay, that's clearly like a hardware design fault then.
No, because it wasn't doing this on Chrome OS. It's just it's just the quirks that you find when you're working on like firmware development. So yeah, like you have battery charging, sensors, bunch of other stuff. What else? Like, I cannot think from the top of my head. Like, the interesting part is that, for instance, the keyboards on laptops, like embedded controller usually, well, sometimes it's called the keyboard controller as well, because it basically takes inputs from the keyboard matrix, and it's usually emulating the PS2 keyboard on the host side. So it takes the inputs from the keyboard matrix, and when like Linux or Windows boots, it says, oh, it's 80 keyboards, so it's PS2. So it's like, well, it's not that much different from PS2 on the desktops, because on Super I/O you also have PS2 controller, but it's basically like a smaller package and more functionality.
I don't even know how long you talked for there about the porting process. I was like, is there a point like I can jump in and like add, like maybe like say something and you just going. No, that's totally fine. I've said this to plenty of people. The more the guest talks, the less that I have to talk, which is always nice. I'd much rather that than people who I have to like prompt to say every little word. So if you can talk for 30 minutes about the porting process, that's all good with me. So when you're in the compilation step there, it seemed like it was basically like every little thing that you might want to enable or disable, there was just like a little toggle there for pretty much everything you wanted.
Yep. Because that's the, I think, well, it depends on who you ask, but I think that's one of the biggest problems of Coreboot, why not so many people choose to use it, is that when you choose everything at the build time, if you want to change configuration, you have to refresh the firmware, which is good if you have like a server farm where you want to have the same configuration across the board. But if you're a user who wants to go, like when you have the UEFI, you go and change like one setting that you want. And we don't really have that in Coreboot, which I would say pushes people off, because they're like, oh, I want this thing to change this thing. Oh, I have to recompile and refresh firmware. Like, screw that. So there are ways to fix this. Like, you can, for instance, set like FSP parameters to say, oh, if the CMOS setting in this position is this, then configure this as that. Then you can either write like EDK2 application or do it from Linux to write to CMOS and switch the settings. But because this project is like mostly used by engineers, like no one can really bother to do that.
Mhm.
So that's the reason I think why so many people still stick to like AMI or EDK2, because it just offers more user-friendly interface.
Mhm. Well, actually, I was going to
Like,
ask you about the limitations of Coreboot, and I guess that sort of leads perfectly into it. So, if there is anything else there that you might want to add to that, then yeah, go into that, I guess.
yeah, like the biggest limitation is that, like I said, it's not very user-friendly.
Mhm.
We have documentation, but it really needs refactoring. Like we have partial documentation on x86, but it's not great in my opinion. And when it comes to like ARM or RISC-V,
Mhm.
there is basically no documentation.
Mhm.
So, you know, I've seen some work being done on Ampere side of things, and it's kind of frustrating that you get basically like binary blob, like on x86 you get binary blob that is under NDA, and if you want to initialize the platform, it's basically like a giant blob that is starting and then passing to the bootloader. Then what's the point at this point? Like, what's the point of having Coreboot? Like if you can just load the payload directly from the firmware provided by the vendor.
Mhm.
But I think it needs more work, and I'm hoping that the documentation I'm in the process of writing will help more people learn and bring more contributors,
Mhm.
because like people here are in the project are very friendly, and they are willing to share their knowledge. It's just that engineers being the engineers, no one really has time or motivation to write documentation.
Right. Right. Yeah, that's a problem regardless of where you exist in the tech stack, whether it's at the level of like, firmware development or at the level of desktop development. Documentation writers are special kinds of people, and you should respect everyone who wants to dedicate all their time to writing documentation because they are a very rare breed.
Of course, and I do appreciate it. Like, I think last week I met a person writing Arch wiki and documentation for Arch,
Mhm.
and I
Mhm.
was like, great job. Like, no matter which distributions you use, you essentially go to either Gentoo or Arch wiki to
Mhm.
get the information you need.
Mhm. Yeah, I'm definitely not the kind of person who likes to write documentation, but I've spoken to some people that do. I don't understand them. I don't get them at all, but hey, you do you. I'm not a designer either, but if that's your thing, more power to you, I guess.
I mean, that's also a way to contribute, right? Like,
Mhm.
if you maybe are just starting with like coding and such, if you just hang out, if you write documentation, by proxy you also learn, right? Because you have to document all the process. You need to understand the code at least to some point. So in my opinion, it's a really good way to start actually learning like how to do this development, right?
Mhm.
Like, because most of the knowledge is unfortunately stuck in our heads,
Right, right.
and if you have the knowledge in your head, you can do that. But then someone comes around and they're like, "Oh, I want to do this," and you see them struggle, and you're like, "Okay, give me that. I'm gonna do this for you."
Mm. Right, but
So yeah,
that's just not really a scalable solution
true.
unless you want to spend all of your day just helping people and never actually getting anything productive done.
Yep, I can definitely relate to that.
So one thing I want to ask about is the relationship between Coreboot and then these like community images that exist. So things like a LibreBoot, Desharo, things like that. Like, how does that relationship sort of, I guess, play out?
Right. So you have like excuse me. You have like quote quote Coreboot distributions like Dasharo, like sorry, like Mr. Chromebooks, like Dasharo, Mr. Chromebooks, LibreBoot, so on.
Mhm.
And basically, how that works is that because Coreboot is GPL2,
Mhm.
they have their own forks focusing on like Dasharo is focusing on like user friendliness. LibreBoot is focusing on getting rid of all the binary blobs. Like I think recently they started doing stuff with Haswell uh, and such. Basically, what they're doing in their projects. I've seen like Liaro and or Michał Żygowski hanging out in the spaces like IRC, and basically they just say, okay, we've done that in the project. Do you guys want this upstream? Or they just push it upstream and let us review the code.
Mhm.
So they basically contribute code. Uh, Sometimes they do it, I would say, better than other times, but generally they do contribute the code back,
Mhm.
which is great to see.
So you mentioned it's like a distribution of Coreboot. Like, obviously, the term distribution is commonly used in the context of Linux distro, but what do you mean by distribution in this context?
Yeah, so those projects basically take like Coreboot 3, they like drop their patches on top of like if it's not in the upstream. Like for instance, I think 2 years ago, Coreboot dropped support for AMD 14, 15, X16 generation of CPUs, which is like FM2 or AM3, basically like a decade old stuff. There wasn't a good reason for this, just no one wanted to move them forward to the new resource allocator,
Mhm.
but no one worked on it, so it's been dropped. But in some of the forks that you might have, they still maintain support for those platforms because
Mhm.
they have user base and they just care more about those platforms.
Right.
Then you have like focusing on user experience. Like you have heads, which is focusing on security. You have LibreBoot, which is CBIOS plus Grub, I believe, which is basically getting rid of all the binary blobs. Then you have Dasharo from 3MDep, which is focusing on user friendliness. So you can, when you buy like Nova custom laptop or something, you can go to EDK2 and change like if you want to uh, enable like resizable bar support and that kind of stuff, like you would on the AMI firmware.
Mhm. Right. Okay. So you've mentioned a lot that Coreboot is kind of, I guess, unapproachable for a lot of people because lack of documentation, all of this stuff. But if you are someone who is a non-technical user, maybe you didn't install Coreboot yourself, but you buy a laptop that has been core booted, whether it's System 76 or anyone else that might provide them. Is there any reason why like a non-technical user would care about core boot, or is it really something that only people who want to get into the weeds of stuff actually are gonna even think about?
Yeah, so I would say it's mostly how much you care about security and and how much you trust the firmware that your system came with. Like a lot of people don't care But then again, a lot of people just buy a Windows laptop from the store and that's what they use.
Right.
And, that's up to them. But if you're like a technical person, let's say, if you are running Linux, then I would say there are plenty of reasons. Like, for instance, on the shelf, I have the MSI mainboard that 3M ported Coreboot to.
Mhm.
And when you boot Linux on it, it spews a lot of ACPI errors. Mostly works, but sometimes it's buggy. And if you check like kernel source for Linux, you see that ACPI.c has a lot of quirks like on this system, disable this interrupt controller because, or like sometimes you put the system and you get IRQ9 nobody cared or something like that. So a lot of vendors simply don't test their firmware that well, I would
Right.
say. Like, they care about Windows and that's it.
Mhm.
But if it works with Linux, then that's basically up for Linux community to take care of it, right?
Mhm.
So, for instance, every vendor has their own like embedded controller firmware, like Lenovo. Framework. Well, Framework is using Chrome OS embedded controller, but like Lenovo, like Asus WMI, Windows Management Interface, all of that has like ACPI specific quirks to control stuff like fan speed. Well, backlight is mostly done standard, but like fan speed, like custom features, like one of my friends has Asus Zephyrus with like a LED display on the lid. So that's all done by API, right? Via
Mhm.
API calls, you set the basically you set the commands, let's say.
Mhm.
And a lot of times it gets a lot of reverse engineering, even with like Windows drivers and so on, to get it working.
Mhm.
So if you buy a laptop with Coreboot and you use Linux, it's basically guaranteed that it will work because people who develop Coreboot are pretty much always using Linux.
Mhm.
So basically, it's putting, well, let's say UEFI that is being done by vendors like AMI and then put on mainboards like MSI. That's mostly targeted towards like Windows. It's best tested on Windows, and
Mhm.
and with Coreboot, if you buy a mainboard with Coreboot or laptop with Coreboot, or if you install Coreboot yourself, then it's pretty much guaranteed that it will work as it should with Linux without any quirks with like fan speed and so on.
Mhm. Mhm. Well, any quirks unless we're talking Chromebooks, which are just weird.
Well, I mean, at this point, it mostly works. We don't have HW1 driver, but you can control the fan using EC2, and you can temperature monitoring works. Like automatic fan control should work over DPTF, right?
Mhm. Mhm.
Or if you have an AMD system, then it should be done via embedded controller. But it's mostly working just fine.
Mhm. Mhm.
Like, the very nice thing about Chromebooks is the audio.
Mhm.
Mm, like the laptop that I have in front of me, it is a brand new machine that did cost like 1,500 euro, and the audio on it is so terrible. I literally cannot listen to the speakers. And if you connect the headphones, it's not even better. Sorry. But then you grab like Elry that I have here, and the speakers sound pretty good. Like,
Mhm.
I could even make it better because we can still throw DSP tuning in user space.
Mhm.
But because we have DSP on those systems, then the speakers sound a lot better than they do on most x86 laptops.
Mhm. Mhm. So one thing that I don't know how hadn't come up yet, but what is your like sort of I guess we kind of touched on this a bit before. What is your background in Linux, in programming, getting involved in the Coreboot project, and yeah, just generally how you got to where you are now?
So I would say that I started like maybe around 2016, maybe 2017. At the time, I was using ThinkPad T420, I would say. Uh, and I wasn't really satisfied with the performance of the integrated GPU because at the time I think I was still in college, yes, or high school, whatever you want to call it. And as one does, I was carrying that laptop to school, and I used to slack off like at the back on the back of the class, playing games like Schoolgirls or Life is Strange. But once I upgraded my display to 1600 by 900, the HD 3000 iGPU on Sandy Bridge was no longer enough. So I've read that with Coreboot, you could replace the CPU with a third generation instead, which had much better iGPU. And I basically tore apart the laptop. I flashed it. Well, I bricked it few times at first, as one does. But I eventually did get it working, and it was pretty much flawless. Then I was like, oh, that's just really interesting. Then I bought the super cheap AMD platform. Was like, I think it was like from a company called Medion, but it's like MSI OEM. I could grab it from the shelf, but I'm too lazy to get up. But I basically ported Coreboot to that. I learned how to do it. I never did finish it because I had issues with like AMD GPU initialization. But at the time I was still like, I would think I was 19 at the time. But after that, I didn't have much time, and I basically kind of left the scene. It wasn't until 2021 when I was working for IBM, and I was really, really bored maintaining legacy systems like AX and Solaris and that kind of stuff. And I looked at the pricing of Chromebooks. I was like, oh, damn, that is, really cheap. And I saw that they weren't supported. I was like, maybe I can work on that. And then I think 2 months later, I really wanted to get it working because at the time I lived in a city called Katowice, which is not super close, but it's kind of close to Ukraine. And you know what happened in February of 2022? And everyone went into the state of panic, like, we will have to pack, we will have to run. So I was really glad that I bought that Chromebook and I wanted to get it working. So the motivation was sky high. And, I basically spent, I think, 2 weeks straight just working on Coreboot and Linux on that laptop. I got it working, it was perfect. And then suddenly we started getting more and more people interested in the project. So we started getting more hardware, more people. And that's basically how I started. I found that audio wasn't working at all on the, I think, Skylake and newer, because that's when Google started using smart sound technology, which is basically AVS/SOF, was audio, voice, speech, and sound open firmware. And no one really cared about getting that to work. So first we had to, we got Coreboot with EDK2, we patched the ACPI, we talked to folks at Intel who helped us debug the stuff, who updated the firmware builds and so on. And eventually we started upstreaming that stuff and, started getting more people interested, more hardware, more work, and the ball started rolling. So I would say before 2022, I mostly had experience with just hacking stuff like reverse engineering, like let's say USB drivers or um, like messing with like Arduino, Raspberry Pi, that kind of stuff. But it really wasn't until I got into Chromebooks related stuff that I got interested in like proper kernel development.
Mhm.
And again, I don't have many patches in like Linux upstream, mostly because upstreaming is a pain in the ass. Thanks to thanks to having to mail your patches, and then they bitrot on patchwork for months. But yeah, it's mostly been okay. Then we had to work with distributions like with Fedora and other to actually enable the modules for the audio, and it's been fun.
Mhm.
Then I would say for the past year and a half, like most x86 stuff is working, and last year we started working on ARM. However, this year I really haven't done much because um, like last year I moved to France, and I found that I had celiac disease. So as you can imagine, if you cannot find gluten-free food, you will have a lot of health issues, which I suffered. So this year for me was pretty quiet, and but then about 2 months ago, as you know, I moved to Germany. Like I started working for 9 Elements, working on firmware as on the more like a professional level. So that's where I am right now.
Mhm. So going back even further, so you started the story on a ThinkPad T420. Going back like much further than that, when did you first gain an interest in Linux and an interest in programming? Because most people don't just suddenly appear on a on a Sandy Bridge system in 2017.
Yeah, so I've been using Linux for 16 years at this point,
Mhm.
which makes me feel old.
Do you remember what your first distro was?
Ubuntu 804 LTS.
Okay.
You know, that GNOME 2 running on Pentium 3 with NVIDIA like FX 5200, I think.
Mhm, mhm,
And it was something different, like not like Windows XP or Windows 98.
mhm,
You boot up Linux and you're like, oh, you can do so much stuff here.
mhm.
Like back then, of course, like gaming wasn't that great because we didn't have the DXDK and stuff. But you could still run some stuff. Like I remember that back in 2013, I was carrying like a Turion 64 laptop.
Mhm.
It was a very heavy beast that was overheating all the time. Uh, so I had it running Gen 2 as well in Dawson High School.
Mhm. Mhm.
And yeah, I used it to play like Minecraft and World of Warcraft. But at some point, the laptop died because, of course, it was overheating. And that was the era of the substrates not being done correctly. So at one point, it just died,
Right.
and I had to replace it. Well, it wasn't surprising that it died because I got it for a super cheap price, and I just revived it by blowing the hot air from the hairdryer onto the GPUs. As one does.
Yeah. As one does, I guess.
Yeah, so basically that's how I got the laptop for about the equivalent of $25 back in 2013, right?
That if that thing does anything, I think that's money well spent.
I mean, it worked for a year, so it was pretty nice to have a laptop,
Mhm.
So yeah, and after that it died, and I saved some money. And at that point, I remember for my after I think I turned 16, my brother said, "Hey, why don't you come over to the UK and you can do some summer jobs, you can save some money." So when I lived there for like 2 months, I saw the ThinkPad T420 on eBay for, I would say, 140 pounds,
Mhm.
and it was brand new. It was just decommissioned and it was never used. So I got brand new laptop for 140, which was great. And
That's
that thing served me well.
yeah,
I
that's
think I would say, yeah, until 2019.
mhm.
So again, for 140, I got 5 years out of it. It was pretty nice.
Yeah. That's a pretty good deal. It's not the fastest of machines, sure, but
I mean,
it's cheap and it works, and that's all that matters.
yeah, and I mean, those systems had a really nice keyboard. And I mean, back then, before, um, like before when you like okay, I don't want to sound pretentious, but like before like Wayland, before all the new stuff we got,
Mhm.
like those older machines, especially before like everything was Electron, those
Mhm.
machines were still pretty fast. Like you didn't need to have like 16 gigabytes of RAM to have Discord running.
Mhm. Yeah, the Electron app problem. I get from a developer perspective why Electron is really popular. Like if you're building, like if you have your application as a website already, and then you want it to be cross-platform, and every single developer on your team is a web developer, I get it. I do. I just don't like it.
Me neither. Like I don't remember. I don't think if you. Sorry, I'm not sure if you remember. Like IAMs, like maybe like Pigeon, for instance. Back in the day, you would have like a Pigeon or other kind of IAM
Mhm.
that had plugins for popular services, and it would just you installed the plugin, you logged in with your credentials, and basically it had all the API implemented.
Oh.
So
Yep.
back in like I'm Polish, so back in Poland, back before like Facebook Messenger came and Google Hangouts, RIP by the way, um, we used something called Gadu Gadu, which was kind of like equivalent of AIM in America, I would say. It was a very simple protocol, kind of like XMPP.
Mhm.
But so you had a very simple program that you could even run on Windows 98, and you could talk to people, like send messages and so on. And that took like what, 1 megabyte of RAM? So
And
now imagine if
mhm.
yeah, so imagine if these days like Discord wouldn't be no using third-party clients is against TOS. Like imagine if they just opened the API.
Mhm. That would be nice. That would be nice. Well, that's one of the things I like about the way Twitch does their chat system. Their chat system is just IRC. Like you can just connect to it from any IRC client. It's obviously the way they do their emotes. You want those to be rendered nicely as well. So you want to have a custom IRC client. Sure, that's fine. But like the backend protocol, nothing special about it. You don't need to reinvent the wheel. There's like I don't think there is a functional reason why the Discord chat system couldn't just be IRC on the back end. Like if they actually wanted it to be.
True. Like there is a plugin for Pigeon, like I mentioned,
Mhm.
and unfortunately, like it works, but it's not that well maintained.
Mhm.
So technically, you could use it in Pigeon. I've seen some people who are like still using Windows XP for fun,
Mhm.
who are using Discord over Pigeon
Mhm.
because it's still supported. So like it clearly can be done, and it will reduce e-waste a lot. So like,
Yeah. Well, that's one of the things that I've I don't know, people are weird about the way they like to criticize certain things, like the Us Here Linux project. Like, why would you care about Apple devices, or the whole getting Linux on Chromebooks? Like, why would you care about Chromebooks? But these devices exist. Like, they're not going to suddenly just stop existing and everyone's going to use these nice devices that are like open, you can just like hack on them. So if these devices are out there, I think it's a good thing that there are people who want to go, and whether it's they're doing it because they want to revive the devices and keep them alive for years in the future, whether it's because they just have a device and they just wanted it to work, whether it's because, you know, they just think they're cool. I like there are people out here that are actually making these devices more usable than they were before, and usable for a lot longer than they would have been before.
yes, of course. And also it helps people in less, I would say, fortunate situations. Like we had a lot of people from, I think South Africa it was, like they're going through energy crisis right now. Like they have a lot of issues with power grid. And so, you know, the economy is taking a downturn. But because the Chromebooks are so cheap and they're pretty much everywhere as a e-waste, and they have good battery life, the having a Chromebook for those people, like even like from 2015, it can get them through the entire day on battery when they don't have power in their homes. So, you know, one of the reasons what keeps me going in the project is that, you know, helping people who wouldn't have access to like technology to learn otherwise have something that they can use.
I hadn't even thought of it from that perspective, but yeah, no, that actually does make a lot of sense as well. Because I always thought about it from like the perspective of like the desktop systems, but yeah, I guess there would be a lot of people who would use laptops with intermittent power as well, and I don't know why I'd never thought of that. I actually don't know why I'd never thought of that.
Yeah, because especially when you have those, sorry, I keep bumping my microphone.
No, it's all good. Don't worry about it.
Like especially when you have those low power devices which could last like 12 hours on battery, right? You can easily get like a power bank, charge it when you have power. So you get a Chromebook that lasts you 12 hours on battery, and then you have a power bank which will last you another 12 hours or so, and then you get 24 hours without the need for, you know, having to plug in into the power outlet, right?
But there's also just the fact that, like, you know, there's some really cool devices out there, right? Like, obviously that's cool as well. But there's also just some really cool devices out there, and you know, people have had this interest in getting old ThinkPads and all that for a long time, and I get it, right? Like, you know, especially the older ones, there's a bunch of add-ons you can get onto them. You can like attach a giant battery to the back. They're really cool devices, but as you've like showed, there's some really cool Chromebooks out there as well. Obviously, there's a lot of them which are, you know, the ones that are designed to go to a school, and they are just, you know, they make them as cheaply as possible just because they know they're going to get damaged. But what we have as Chromebooks now aren't just what existed then. Like, there has become this actual like laptop market in the Chromebook space as well. Like, we're really far past what you had on this thing, which was like 32 gigabytes of internal storage. Like, you can get like actual usable amounts of storage, usable amounts of RAM with these devices now. And because people don't really, you know, consider them in the same way as they do with ThinkPads, you can get some pretty crazy deals on them as well.
And the nice part is that if you get like 11, 12, 13 generation, anything with Core i, like Core i3, Core i5, Core i7, all of the system now, even if they ship with UFS module, because previously it was eMMC, but now they ship with like UFS module, you can remove the UFS module, install NVMe drive, and flash the custom firmware, and then all of a sudden, for instance, my laptop came with 128 gigabytes SSD. But as of right now, I think I have Samsung 980 in it, 1 terabyte.
That's a pretty good upgrade.
Yeah. So, I mean, and also the performance, right? Maybe as I said, maybe I can show you what you can do on those Chromebooks because, like you said, like the
Well,
nice
besides
part
the one
about
that melts when you when you have it on.
yeah, I mean but the nice part about the it's called Education Edition, because they are designed to go to schools, they are regularized like for around the screen and around the palm rest. Usually, you have a very thick rubber coating. So if you drop it on the floor, it's not gonna break. I will need my HDMI capture to show this. Now, unfortunately, unlike some older systems, on those ones, you will only get the video output once on the external monitor, you will only get the video output once the Linux kernel will do mode setting. Because if I would want to enable video output on external display in the firmware, I would have to edit the video BIOS tables. But of course, because this doesn't have HDMI, I will need to use a dock, and I will likely also need the power, which I actually prepared something for once. Nice. So we get the power, we get the HDMI. I'm gonna.
Now we see if it works.
I mean, there is no reason why it shouldn't.
Live demos.
Yes. Doop, doop. Okay, it boots. And also the interesting part about this one is that one of my friends got it from eBay.
Okay.
So like it came with broken screen, so it means that I don't have touch screen. However, my friend got this 11th generation Chromebook for £20.
Wow. Okay.
Because who cares about a broken Chromebook, right? So let me see if I will be able to do the video capture here. Now, which video device will it connect to?
That is the question.
Yes, because I have 7 video for Linux things right now.
Do I want to know why you have 7?
I don't know. I know that 3 of them is the internal camera, and I think another 2 are the Windows Hello cameras in my laptop.
Oh, that makes sense. Okay.
Then 4th is the camera that I'm using right now. I don't know what's on 5th and 7th, but it looks like video 6 is the input I'm looking for. So I have a very bad habit of saying my password out loud. So okay.
Ooh.
I don't want to be too loud, even though I'm the only one in the office. And I could pass through audio through HDMI, but I don't think we will need that for the demo.
That's fine. That's fine. Yeah.
So let's just because I have 1% of battery, so I have to be quick with the dock. Okay. 1 second. What happened to my display now? Okay. So I did F11. All right. So I'm going to enter the tablet mode, and I'm just going to share my screen.
Okay.
So you will see yourself for a second, because I don't want to mess around with the webcam input.
Fair enough.
Okay, so let's see. Displays. Okay. The question is, did I grab the working HDMI cable? Because as you can imagine, when you're moving to the different country, sometimes you might get the broken cable.
Right.
So, okay, looks like that actually was not the right sync. So video 7, maybe. Yes. No, interesting. Let me just check. Yes, that's the live demo, right?
Oh, absolutely.
Okay, so input for or I can do
Okay.
so we guess. Okay, so we have 2 of them. So, and I think this will be the correct one, but now the question is, will this HDMI cable work?
If it doesn't, it's not a big deal.
I mean, I can just go and grab another one. Because it will be really cool to actually show it, but again, I can also show this via the webcam. It's not a problem. It's just, like you said, it's the live demo.
Yeah.
So let's quit out of that, and I'm going to stop the screen sharing.
Okay.
So instead, I'm just going to hold my laptop up. So, so all those people that say, "Oh, the Chromebooks are slow, they're useless." Before Google introduced Steam on Chrome OS, which is still in beta, by the way, we were the first ones to actually run proper games on it. So, since this is an 11th gen system, let me just. It will be much easier when it actually launches. And this is still a modern game, right? So the question is if I'm connected to the Wi-Fi, because I don't think I use this system here. I'm not sure if this can. And did I forget the? No, I did remember to bring it. So like I said, this is the 11th gen, and I think everything is working except for the fingerprint, right? And there is actually someone who is writing the fingerprint driver for those devices.
Oh, that's cool.
Yeah. Like, I think it's a merge request open on 3 desktop libfprintd.
Mhm.
So I'm following this development because at some point I said, okay, at some point I will look into that, but I just did not have time.
Sure.
So let's just go to. Okay, so 1 second. I like you said, live demos, right?
Yeah.
Looks like this game does not like hot plugging the controller. The more you know. Okay. So we go through all this ordeal again. But again, I want to show it because then people will be like, "Oh, you can do that." So I mean, of course, it would be better if we had the HDMI capture, but I should have tested if my HDMI cable wasn't broken. And like this is kind of crusty right now in the menu. But once you get to the gameplay, and again, this is mostly when it's loading assets. So because this is a Core i3 model, so on Core i5 it will be better. But like maybe you will be able to see.
Oh, yep.
It's pretty smooth. Of course, it is low settings, but it is in 1080p. So this is the modern game running on iGPU.
Actually, kind of impressive.
Yeah. I was like, maybe this will probably not work, but I was curious. And initially, I had issues with Proton not being able to use the sound card for some reason.
Okay.
Let me kill it. Okay, how do I kill this game? Mute. Right. So initially, I had issues with Proton not being able to use audio, but then I found that I had old UCM configuration on the system. So when I updated my UCM config, that to have what we have in the repo, it just worked.
That's always good.
Yeah.
It
Like I
just
said,
works. That's the best state for things to be in.
Yes. So, of course, this still could use some work. But again, considering this is the project that we maintain like 4 people in our free time, I think we're doing pretty well.
Yeah. Well, on that note, we probably should be ending this off.
Okay.
We've just gone past the 2-hour mark.
Is there anything else we should cover? Like we went through like porting process. How is the platform initialization stuff? Maybe I should just add that AMD is currently working on OpenSil, which will replace AGSA. And it will be a much better experience overall because then what is currently closed on Intel side in FSP will be open source. However, because they cannot release the memory initialization code, they will have to move it to PSP. Like AMD has equivalent of management engine called the Platform Security Processor, which is a really tiny ARM core that is running, all the firmware. So basically, the way they will do it is that upon deploying the system, the boot ROM will boot the PSP. It will initialize the memory, and then it will basically when the memory initialization on PSP is done, then it will reset this x86 cores from reset, and then you get all the firmware that will be using OpenSil. Because a lot of companies these days don't develop their own memory controllers. So I don't know which one is it, but I think they bought the DDR5 controller from Synopsys. So that's why there's that concerned that they cannot open source it, so they have to hide it somewhere, and they're working on it. So I think they should be ready for 2026. Like, that's the roadmap. So if anyone is interested in details, I could recommend, I believe his name was Paul Grimes from AMD, gave a talk at Open Source Firmware Conference this year about that. So hopefully, that's better for us, like more open silicon initialization, more transparency. So fingers crossed.
So if people want to get involved in Coreboot, they want to go and use Coreboot, all of that stuff, where can they go to find all that?
Well, we have community split between IRC. I think we also had Matrix Room, but I'm not active there.
Mm-hmm.
We have Discord, but then again, Discord being Discord, it's not great for being a resource. And I would say probably the best place for now is still IRC,
Mhm.
or if they just want to like hang out and ask us, how can they do thing X, then also on our Book Discord we have a channel of topic development, which no one really uses, but if you have any Coreboot related questions, if you are unsure if you can do something, then you can ping us there. And if not, then there's still some people are active on Coreboot's Discord these days, so probably someone will respond. It's just that you have people from all the different time zones, and sometimes it might take a while for people to get back to you.
Right. Is there anything else you'd want to direct people to, or?
I mean, not really. Like, if you're interested in meeting like developers, then of course we are at FOSS every year. We have our own dev room. I think some people are going to FOSS Asia as well. We have Open Source Firmware Conference, but that's more, business oriented. And then also we are present at conferences like, like next month there is a Chaos Communication Congress in Hamburg in Germany. So we will have our own assembly. So if you're there, just feel free to pop in, talk to us. Don't worry, we don't bite.
This is the part where you plug your employer if they need Coreboot consultation work.
Yeah, I mean, sure. If you would like, if you are like a board vendor or a system vendor, you can send an email to Christian or the contact at 9Elements, and
Well, is there anything else you want to mention, or can I do my outro and then we just we can sign off?
Well, it was kind of chaotic, but I think we covered everything we wanted to say. Like, like we could, in theory, talk about like Qualcomm stuff, but let's not get into ARM like at this point, because it is very much a work in progress. So.
Well, we can certainly talk about more stuff in the future. There's no reason why we can't do a second episode at some point.
Yeah, sure.
And hopefully that time it is not going to be... Well, hopefully next time we don't have an hour delay before we can start recording. That'll definitely be an improvement.
Yep, I mean, I will do my best to get the camera sorted. Like,
I think, to be fair, half the problem was Discord. So I don't think you take the full blame for that one.
Yeah, true.
So as for me, my main channel is Brody Robertson. I do Linux videos there 6 days a week. I've got the gaming channel, Brody on Games. Probably still streaming Kingdom Hearts 3 and Black Myth Wukong, so check that out. I've got the React channel, Brody Robertson Reacts, where I just upload stream clips. And if you're listening to the audio version of this, you can find the video version on YouTube at Tech Over Tea. If you'd like to find the audio version, it's going to be on pretty much every audio podcast platform. There is an RSS feed, so put it in your favorite app and you're good to go. I will give you the final word. How do you want to end off the show?
I'm not good at intros and outros, but, for anyone who went through the entire episode, I would like to thank you. Like, it was definitely a bit chaotic, but then again, hopefully people will find some value in those 2 hours that we spent talking about the project and semi-related stuff.
Yeah, that works.
Okay, then